In today's video, I'm going to talk about land use change and the effects that has on the carbon and water cycle. This is part of the OCR A-Level Geography Spec 3.A. First of all, I'm going to look at urbanisation and the impact that will have on the water cycle. So here on the left-hand side, we see some tarmac. If I put lots of artificial surfaces like tarmac, which is impermeable, then that is going to affect the water cycle by reducing infiltration rates. Very little water will be able to get into the ground and pass through the soil as free flow. With low infiltration rates, therefore, it will go along the surface as runoff, and therefore it's going to get into streams quicker. We're going to see a rise in discharge and water levels in local rivers and streams. Similarly, if I build a lot of buildings, they're going to have sewage and they're going to have drains and they're going to have gutters. And all of this does with the water that if there wasn't any urbanisation, which would naturally go into the soil and slowly go through the water cycle, it's going to speed it up. It's going to remove it quickly from the area, straight into streams and rivers. So we get that lag time being reduced and water getting into streams and rivers quickly. Another way that urbanisation can affect the water cycle is when we build on floodplains, that takes away that natural buffer. So if there wasn't development, then the water would naturally just go onto the land either side of the river and be stored on the surface until it evaporated away. But if I put buildings there, then we're going to have those buildings being damaged and that buffer is being removed. Next up, we're going to look at farming and how that might impact the water and carbon cycle. Here's an example on the left where we can see that a field has been ploughed, and when ploughing has occurred, the actual furrows, which are the kind of lines that happen when a tractor ploughs a field, they have actually gone down the slope. This is potentially bad for the water cycle because it accelerates any runoff. Any water that gets into that field is going to be channeled down these kind of soil channels down to the bottom, and with increased runoff on the surface, you're going to get more soil erosion. On the right hand side, we can see a tractor's been over this land, and therefore because of the heavy weight of that tractor, it's actually compacted it. If I get compacted soil, therefore it's harder for the water to infiltrate in, increases the chances of runoff, and so you might get water moving from that area quickly to a stream, which would cause localized flooding. Here we've also got a comparison between the trees in the background and the crops that have been laid here, and the simple fact that changes the water cycle here is interception rates. If I'm a tree, I've got a bigger surface area, and therefore I can intercept more of the rainfall that's happening, where crops, they not only have reduced interception rates, but because they haven't got such a big surface area which would store the water, therefore they're going to have lower evaporation rates. So if we change the land, we cut down forest and put crops in its place and do lots of farming, then we're going to have lower interception rates and evaporation rates. Last but not least, in terms of farming and the water cycle, we can see that irrigation has happened here, but we need to get the water from somewhere for irrigation. So if we get it from river water or groundwater, then we're diverting it from other stores. This can be problematic because taking, for example, water from groundwater, from an aquifer, if we put it onto the surface, that means more of that water can be exposed, and that can be therefore prone to higher evaporation rates. In terms of the carbon cycle, again, ploughing is a big issue because when I turn over the soil with my tractor and the plough, it actually allows the soil to have more oxygen with it. And when I get more oxygen to the soil, that allows these guys, so this is the fungi, the decomposers, they have more oxygen to be able to respire. If they're respiring more, they're going to be breaking down that organic material and that kind of semi-decomposed material that's under the soil, and that releases carbon dioxide to the air. So ploughing actually can cause a transfer of carbon from the soil back to the atmosphere. Forestry is slightly different. Here's an example of a coniferous plantation. So these trees have been planted. You'd find this in kind of upland Scotland, large parts of the upland UK. And when we get these plantations, they're very dense in terms of the amount of conifers. They're really close to each other, and this will affect the water cycle in a couple of ways. They'll have a high interception capacity, not only because there's so many of them put together, but also they're evergreen, so they don't lose their leaves. That means they can intercept all year round. They're also made of these needles, unlike most deciduous, which are broad leaves, and these actually are able to trap the water in between the needles. They give it a slightly bigger surface area, and that means the water actually sticks in the gaps, and therefore it can actually intercept more water. And it also leads on to our next fact, so that means it can evaporate from those gaps and into the atmosphere. And so we also, because we're getting evergreen leaves, we're getting high transpiration rates because they don't lose them in the winter. So they can, on an average year, they can actually transpire water for more of the year. So this is showing you that kind of by planting a lot of trees, especially in these huge conifer plantations, we can have, big changes happening to the water cycle. Just a little bit of data to finish us off. An example of a conifer is a Sitka spruce, and if it is in certain parts of England, East England, here's the example I've used here, you get 60% interception. If it was in an upland area where it was actually lower temperatures, therefore there would be less interception and evaporation, probably about half of what that figure is. If we continue on the idea of the water cycle and how forestry affects it, it's not only actually the trees and interception rates. We've already said that evergreen leaves with their needles and the density is going to cause a lot of interception, but that obviously affects the rivers around it. If I've got lots of interception, lots of water being used by the trees, being absorbed by the roots, that means it's going to take actually a lot longer for that water to get to the river. So we're going to have longer lag times in the streams and localized rivers and near plantations, and that means we're going to have a lower peak flow and a lower discharge. This means that in areas near plantations there could be potentially a lot less water available for people to use in their homes and for public use in general. Just a kind of thing that we already talked about before, but if I plant loads of trees, converting it from something like farmland or moorland, then it's going to increase the amount of carbon that actually is stored in the biosphere. This is because obviously trees extract carbon dioxide, they store it in the wood, and they become a carbon sink. Especially when they're growing, they're absorbing lots of carbon and they're storing it in the wood. And to prove this, we can see that nearly 10 times more carbon is stored in a forest than you would be in a grassland. The only issue we need to think about this is that it's not always permanent. When we have more carbon being absorbed from the atmosphere than is being released, especially when a tree is young, we can say that planted trees are an active carbon sink because they are taking more carbon out than they're giving off through respiration and decomposition. That is when trees are very, very young. But obviously, as trees mature, they slow in their growth. And so it's only in the first 100 years, really, that trees that have been planted actually are carbon sinks. And after about 100 years, the carbon that is absorbed is actually balanced out by the carbon released. The carbon released actually increases because there's more decomposition, respiration, because the trees got bigger, and also more of the kind of leaf litter is dropped, and at the same time the growth of the tree has slowed. So what happens normally in these forestry regions, after about 80 or 100 years, they cut those trees down and then replant trees which are very young trees, and those are the trees that grow and absorb more carbon than they actually give off.